Students, now we study errors in a measurement. How to define it? You see, errors in a measurement. Here, errors in a measurement. Now, the errors in a measurement is equal to the difference between the true value and the measured value of the quantity. Mathematically, we can write error is equal to true value minus measured value. There are different types of errors. Number 1, constant errors. 2, systematic errors. Now, in this part of error, systematic error, we are having number 1, instrumental errors. 2, imperfections in an experimental technique. 3, personal errors. 4, errors due to external causes. Now, third type of error is random errors. Fourth one, least count errors. And fifth one is gross errors or mistakes. Now, come to first one, constant errors. The errors which affect each observations by the same amount are called constant errors. Such errors are due to the faulty calibration of the scale of the measuring instrument. Such errors can be eliminated by measuring the same physical quantity by a number of different methods, apparatus or technique. Second one is systematic errors. For this systematic errors, see the errors which tend to occur in one direction, either positive or negative, are called systematic errors. We can eliminate such errors once we know the rule which governs them. These errors may be of the following types: instrumental errors, imperfections in experimental technique, personal errors, and errors due to external causes. Now, let's see what is instrumental errors. These errors occur due to the inbuilt defect of the measuring instrument. For example, wearing of the meter scale at one end, zero error in a vernier calipers, etc. This error can be detected by measuring a physical quantity with two different instruments of the same type, or by measuring the same physical quantity by two different methods. Now, second one is imperfections in experimental techniques. For this type, you see, these errors are due to the limitations of the experimental arrangement. For example, error due to radiation loss in calorimetric experiments, error due to buoyancy of air when we weigh a body in air. Such errors cannot be eliminated altogether, but necessary corrections can be applied for them. Third one, you see, it is personal errors. These errors arise due to individuals' bias, lack of proper setting of apparatus or individual's carelessness in taking observations without observing proper precautions. For example, when an observer holds his head towards right while reading a scale, he introduces some error due to parallax. Such errors can be minimized if measurements are repeated by different persons or removing the personal bias as far as possible. Now come to this fourth type of error, errors due to external causes. For this errors due to external causes, see, these errors arise due to the change in external conditions like pressure, temperature, wind, etc. For example, the expansion of a scale due to the increase in temperature. Such errors can be easily detected and necessary corrections may be made accordingly. These errors can also be minimized by controlling the external conditions during the experimentations. Now, third type of error is random error. For random errors, the errors which occur irregularly and at random in magnitude and direction are called random errors. Such errors occur by chance and arise due to slight variation in the attentiveness of the observer while taking the readings or because of slight variations in the experimental conditions. For example, if a person repeats the observations a number of times, he may get different readings every time. Random errors have almost equal chances for both positive and negative errors. Hence, the arithmetic mean of a large number of observations can be taken as the true value of the measured quantity. Now, fourth error is least count errors. For this least count errors, you see, this error is due to the limitations imposed by the least count of the measuring instrument. It is an uncertainty associated with the resolution of the measuring instrument. The smallest division on the scale of the measuring instrument is called its least count. For example, a meter scale has a least count of 1 mm, 1 millimeter. Its readings are good only upon this value. This error in its readings will be half of this value, that is plus minus. We can write in this way, plus minus 0.5 mm. Now, come to fifth type of error. It is gross errors or mistakes. For this type of error, for fifth error, you see, these errors are due to either carelessness of the person or Due to improper adjustment of the apparatus, no correction can be applied for gross errors or mistakes.